This is Module 8, show that a quadrilateral is a parallelogram. One of the things that's evident about this part of the chapter is it's very similar to the previous module, only in this case I give you the properties and you have to kind of show using similar worded theorems that something is a parallelogram. So, what you know and what you'll learn. So last section we were given parallelograms, and by theorem 8.3 and 8.4, which is in the previous module, we can prove statements about the angles and the sides of the parallelogram. So we have opposite angles here and opposite sides of a parallelogram are both congruent and parallel. So in this section, what we're going to do is we're going to kind of switch it. We're going to take the what's called the converse, and this is from the previous semester's material. So we're going to prove that a quadrilateral with certain angle and side properties is a parallelogram. So in theorem 8.7, if both pairs of opposite sides of a quadrilateral are congruent, then we can conclude that the quadrilateral is a parallelogram. So it basically states that if you know first that the opposite pairs of sides are congruent, we can show that ABCD is a parallelogram. So all it's doing is it's taking the converse, or the switching the hypothesis and the conclusion of the if-then statement. Theorem 8.8. We have if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we know opposite angles are congruent in this figure. So we know angle A is congruent to angle C. We also know that angle B is congruent to angle D. If we know those two properties, it's that it is a parallelogram. Okay, so if one pair of opposite sides, this is theorem 8.9, one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral automatically is a parallelogram. So if we know that BC is parallel to AD, we also know that BC's length is congruent to AD's length, or segment. That means automatically that ABCD is a parallelogram. In theorem 8.1, or 8.10, I should say, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So we have diagonals bisect each other, that's what we know first. And if we know that BD and AC bisect each other, so that means that this guy here is your midpoint, M. So if they bisect each other, we label them as congruent. That means that ABCD is a parallelogram. Alright, some application with this. So in quadrilateral WXYZ, we know that the measure of angle W is 42 degrees. We know measure of angle X is 138. Angle Y is 42 degrees, and we're asked to find measure of angle Z. So first it's asking, is WXYZ a parallelogram? So the first thing you have to do is you have to draw it. So I'm going to draw something that resembles a parallelogram. It could be a parallelogram, it might not be, but it is a quadrilateral. I'm going to start off with the first letter they give me, go around clockwise or counterclockwise, it doesn't matter. W, X, Y, Z. So we have W, angle measurement is 42 degrees. We also know that angle X is 138 degrees. 38. And last but certainly not least, we know that Y is 42 degrees. So I can stop here. I see a couple things. I notice that both angle W and angle Y are congruent, or equal. I also notice that these two guys are consecutive interior angles, and they are supplementary. If they're supplementary, that means these two lines have to be parallel. The same thing holds true for here. That means these two lines have to be parallel as well. So if that's the case, automatically I've shown that I have a parallelogram here. I could just show it easily by saying consecutive sides or consecutive angles are supplementary, and we conclude that both pairs of opposite sides are parallel. I could also say that if I have these two sides are parallel, I could also show that angle Z, which is what we're trying to find, since these two lines are parallel, that means this is angle Z. We can say that since it's a parallelogram, opposite angles are congruent. So I can state and angle Z is 138 degrees. The other way of doing it, if you saw, you could also use these two angles to say that they are consecutive and they would be supplementary. So, my reasoning, my conclusion, would be WX segment is parallel to ZY's segment. I also know that WZ's segment is parallel to XY's segment. So, because both pairs of opposite sides are parallel, that means that it's a parallelogram. So we would say yes, because both pairs of opposite sides are parallel. Okay, so for what value of x is a quadrilateral CDEF a parallelogram? So this is kind of tricky because it doesn't tell you that it's a parallelogram. It's asking you what value for x would make this a parallelogram. So we need to know, in terms of diagonals, what's true about diagonals in a parallelogram? Well, diagonals bisect each other in a parallelogram. So I know that this is congruent to this. That means if this is a parallelogram, we're trying to find the value of x, that means this segment has to be congruent to this segment, which means that you can state that 5x minus 8 equals 3x. When you solve, subtract 3x, you get 2x, add 8, and then divide, you get x is equal to 4. So that's the value that would hold true to make this a parallelogram. Okay, so we have an amusement park ride has moving platform attached to 4 swinging arms. The platform swings back and forth higher and higher until it goes over the top and around in a circular motion. In the diagram below, AD and BC represent 2 of the swinging arms, and DC, they tell you, is parallel to the ground. Explain why the moving platform, AB, is always parallel to the ground. Okay. So here's the explanation. We have the figure here. The shape of quadrilateral ABCD changes as the moving platform swings around. Its side lengths do not change. So AB and DC, those lengths do not change. And BC and AD, those lengths do not change either. So since we know that both pairs of opposite sides are congruent, that means it has to be a parallelogram, because again, we know this is 16, this is 16. That's one pair of opposite sides. This is 38, that means this has to be 38. So both pairs of opposite sides. Once we establish that, that's definition of a parallelogram. AB is parallel to DC. So once we establish it's a parallelogram, we can say all of the properties of a parallelogram hold true. Opposite angles are congruent. Consecutive angles are supplementary. Both pairs of opposite sides are congruent. Both pairs of opposite sides are parallel. One pair of opposite sides is congruent and parallel, and diagonals bisect each other. So, again, the moving platform is parallel to the ground. All right, so in construction, this is a very important thing. So we have something that's a little misshapen in terms of a doorway. So we have the doorway shown is part of a building in England. If you know anything about architecture in England, it's very old, so it actually does shift over time, or has shifted over time. So the building has leaned sideways. Explain how you know that SV is equal to TU based off of the labeling. Well, based off of this labeling, this is what I'm given. That's it. So which one of our theorems actually shows that this is a parallelogram? Okay, so we know that ST is parallel to UV, and ST is congruent to UV. So if we know that, automatically this is going to be a parallelogram. So if we know it's a parallelogram, automatically we can conclude that SV is congruent to TU because we've established that it is a parallelogram. SV segment is congruent to TU's segment because of the definition of a parallelogram. We've already established it's a parallelogram. That means, again, all the properties hold true for a parallelogram. So, summary of ways to prove a quadrilateral is a parallelogram. One way, show both pairs of opposite sides are parallel. Show both pairs of opposite sides are congruent. Show both pairs of opposite angles are congruent. Show one pair of opposite sides are congruent. Show the diagonals bisect each other. And we also know consecutive angles are going to be supplementary. That's one more thing. Alright, so with that in the previous one, what theorem can you use to show that the quadrilateral is a parallelogram? So for this, the best way to know these is not by the number, by the theorem number, is by the actual definition. So what do I see in this first one? I see that I have a side opposite another side is congruent. I also see that a side opposite that same congruent side is parallel. Is that one of our theorems? Absolutely. So, opposite sides are parallel and congruent. That shows that this is a parallelogram. What about number 6? Well, in this case, what I see is I see that I have one pair of opposite sides are congruent. I have two pairs of opposite sides are congruent. So if I have two pairs of opposite sides that are congruent, is that a theorem that we have that proves that quadrilateral is a parallelogram? Absolutely. Both pairs of opposite sides are congruent. Now, number 7, it's kind of up to you which one you want to use. I personally, just because I think it's easier to remember, I see that I have opposite angles are congruent. Both pairs of opposite angles are congruent. So that would be the theorem that I would also use. But again, what you could use, if you wanted to, was the last one that we went over in the previous slide, is consecutive angles, consecutive angles, consecutive angles, and consecutive angles are supplementary. So either or, does not matter. Okay, next question. So we have, for what value of x is quadrilateral MNPQ a parallelogram? So again, if we know it's a parallelogram, go through all the 6 properties that prove, 6 theorems that prove that something is a parallelogram. Again, we have these two segments here are congruent, which means that's a diagonal, which means that these two segments here have to be congruent as well. Diagonals bisect each other in a parallelogram. So we have 2x is equal to 10 minus your 3x. Add 3x to both sides. Divide. Only value that will give us something true for a parallelogram is the value of 2. That's it.